But I'll just go through some slides really quickly. So most of you guys probably already know what Python is. It's a programming language. So you can build websites, software, automate tasks, which is a big one. Do data analysis. Probably one of the easiest programming languages to learn. Probably like easier than Java and C++, but it can be used in a lot of stuff. It's really useful, and it could be used in reverse engineering and even like cryptography and steganography, like those really complex ones. Okay, so here's some code editors, which is where you'll type code. So you can do it on Replit. That what I've over here. So you literally just Google Replit, and then create an account, and you should be able to create stuff. So I have like something right here. Oh, I don't want this. And then it's running Python, right? So it's running Python over here. And basically you can type stuff here and then it'll output over here. All right, you can ignore what this is. That's right here now. Okay. There's also Visual Studio Code. Is this thing right here. It's a really good code editor. And then there's also PyCharm and a bunch of other stuff you can run Python on. Okay. Here are some Python stuff. You can like print, you can have inputs, all of this. I think doing a demo would be better. So let's do that. So, create a new one. And look at this, you can choose your code editor. So like, right, you can do C++, C, Java, but I'm just gonna do Python. It doesn't matter. Okay. Wait for this. Okay, awesome. So, okay, the first thing I want to teach is that you can literally just do math operations on here. If you do 1 + 2, wait, hold on. I think it's not responding. Wait, hold on. Okay, screw that. I'm just gonna use VS Code. I don't know why it's not working. I haven't used Replit in a long time, honestly. Oh, actually, okay, let's use Jupyter Notebook. I feel like that'd be easier. This is also an IDE that you can use. Okay. Just want Python. Okay. And the cool thing about this one is that you can like organize it into like you can like organize it really well. So let's do like +2 first. Right? As you can see, it outputs 3. So you can just do some math operations, like you can also do multiplication. Right? Pretty easy. Do division. You can also find the remainder, the modulus, which is %. So what this basically does is that it divides number, the first number, by the second number as many times as possible before it before it goes into a fraction. Like 18 divided by 4 would be 2, right? Or I'm not explaining that well. Basically you're like subtracting. Think of it like subtracting this number as many times as possible. So if you keep on subtracting it, it's going to -4, -4, -4, -4. Then that would be subtracting by 16, right? So 18 minus 16 would be 2. That's the modulus. Also print. So like an iconic one is just printing hello world, right? So basically the syntax is you print and then the parentheses, and then you need to have some quotations and then whatever you want to print. So we can do hello, do whatever, right? Okay. And over here, I just have the slides open, so I know what I want to talk about. Okay, so let's do some variables now. So how variable works is that you define something. So we can do like age, and then So this can be anything, and then you basically set a value to it. So if we put age is 24, right? And whenever we refer to age, it's going to be 24. So if we just type age, it's going to be 24, right? If we have blue is equal to 12, we still now age, it's still going to be 24, right? Because its age is 24. So if we do blue is 12, right? And I'm sorry if this is like a review for you guys, but some people don't know Python. Now I'm going to talk about if-else statements. So if we set like age is less than 21, and colon, then inside this if statement, we're going to print you're too young, right? You're too young to drink beer. Okay. Oh. And then we're going to have an else statement. So for all if statements, they're going to be else's. So else, colon, then print whatever, right? You're old enough. Okay. So if we run this, you can say you're old enough, right? Because we have age set to 24. Basically, it goes in here. And if age is less than 21, you print out this, right? 24 is greater than. So we actually go to the else statement, which prints out this right here. But if we have like age is 12 or something like that, right? You're too young, because 12 is less than 21. So it's going to run this print this statement instead. Okay. Right. And then also do this to strings. So right now these are called integers. But if we want to print out a string, which is like, it can be like a name equal to William, right? Notice how I'm doing a double equal sign for this, because a single equal sign would be actually setting a variable, right? Like this one right here. And we don't want to set a variable. We're just doing an if statement. So if the name is equal to William, then we can print, and then we need a colon. And then we can print whatever, right? Hey, William. And then we can do another if statement. So if we want to do another if statement, we can just do elif, which is another if statement. So else if name is equal to Bob, right? We print Bob. And then let's just have an else statement. So if the name is both not William or Bob, let's just print both. So if we run this, nothing's gonna happen, right? Because name is not defined. So I need to define name first. So we need to set the variable, right? So name is equal to, and then let's test out Bob first. So if you do this, oh, wait, okay. I forgot the quote, yeah. Okay, so if we run this, hey Bob, we set it to William, all right, hey William. And if we have the name that's just something random, just says hello. Okay, so that's basically if-else statements. Okay, you can also ask for the user input. So how you would do this is, again, we're going to set a variable. So let's just do input1 as the variable name equal to, and then what you would do is do int, which stands for integer, if we want. So let's just say a user types integer, okay? And then we do input. So that's the syntax right there. I hope that works. Okay, let's try this. Then we want to print out input right after the user inputs it. Okay, so it's asking for a prompt. So if we do like 3, right, it prints out 3. Okay. And then if we want to do something else, like addition, okay, and then set it as input 1 plus input 2, right? So first one, just do 2 plus 3, which is 5. So that's how inputs work. Next, I'm going to talk about lists. So if we have, all right, vehicles, and list is just literally a list of values. So this is the syntax. You do the square bracket, and then whatever you want inside. So we have a car, bus, right, plane, whatever, bike, okay. And you can kind of think of it just like setting a variable. Basically, the vehicles will be this list of values right here. And if we just print out vehicles, right, we get this thing right here. Oh, okay, here's something cool we can do. We can combine these two. So if you do this, and then instead, we're going to print out, right? And then vehicles, we're going to print out the vehicles, and then put 1. So what this is doing, basically, whatever you're inputting is going to be the position of here. So this would be 1, I think. Actually, no, let's start with 0, I'm pretty sure. 0, 1, 2, 3. So that's this. So if we do 0, right, it would be car, okay? So that's the 0th position. If we do 2, that'd be plane, right? 0, 1, 2. Okay, that's basically how it works. I don't want this to take too long. Okay. Let me demo a loop too. So if we do the same thing, we have this. And then we have a for loop. So for V in vehicles, for V in the list, V in vehicle, let's just print out V. And then, okay, so basically what this would do is you're printing out all these values, right? So basically, this will loop through, do 0, 1, 2, 3, 4, and just like all these values right here. Okay. You can also do a while loop. Okay, let me show this. Let's say the counter variable is going to be 3, and while counter is less than 10, print the count. Okay, so you can do anything. Let's just do this. And then the important thing is you write this. You're basically adding one. You're adding 1 to the counter every single time you loop through this. And basically, what's going to happen is you're going to start with 3, right? And then you're going to print this out, and then the counter value is going to be 4. And then you keep on doing this until the counter is not less than 10. So as you can see, you printed a 7, right? Which would make sense. Yeah. Because in the 7th loop, it'd be equal to 10, and this will stop. Okay. So that was like a very basic example of Python. I don't think we need to go through these. Yeah, I think it's fine. I'm just gonna jump straight to reverse engineering. And this is a really hard topic. Okay. Reverse engineering, what is it? It's basically taking a program and converting it into something more humanly readable. So often seen in the form of compiled C code or Python. And certain tools can make reverse engineering easier, like GHydra, Python decompiler, other stuff. So here's some basic knowledge you need. Honestly, I don't think this might not be enough because reverse engineering is really confusing. But um, if you want to like research more after this presentation, you can do that. But you need to know how to use the Linux terminal. Sorry. You need to know how to use the Linux terminal. So I taught that like a few weeks ago, right? You just need to look through those commands. Assembly would be good, but yeah. How any of us have the assembly knowledge. And then like knowledge of how programs work is also pretty important. Because basically what you're trying to do in reverse engineering is like hacking, kind of hacking. You're basically trying to break the program. Yeah. Okay. So here are some types of reverse engineering. There's a basic type. So they give you some Python program with some weird code in it. And you basically just look at it and try to edit it to return the flag, right? So that's a simple type. Then more intermediate, some Python program that obfuscates this flag. So like you can encrypt it or do whatever to it. And you need to find a way to reverse it, the flag. In the hard one, you just assemble a program to figure out what's going on in assembly and use that to reverse engineer the flag inside of it. These are all kind of hard, honestly. Okay, so here is just some really basic example. Like this is a step on how to reverse engineer. You download the file, and then you open it up in Python and read the lines and see if there are any extra functions in the file and what it does. Then you look at the encrypted flag, if there is any, and the process for which it is encrypted. So like in one CTF problem, you see this right here, and you got to use big brain to reverse the process and get the flag. Okay, so here's like an example of how you can practice. Well, first you gotta know what this is doing, right? So basically what this is doing, there's a range right here, and it starts at 0, and it goes to the length of the flag, and it's adding by 2 every single time. And you take the order of the flag character, and you shift it by 8 bytes. So basically, the flag is shifted by 8 bytes, and order of the next character of the flag, and then take the car of the whole thing, repeat until do the whole flag. And then, so someone else on my team does this. I don't know how they do it, honestly. But you get like an encoded string, and then they basically write a program to do it. I think I'd just be better off looking at some CTF problems. Okay. You can probably see that solve rate on these are like pretty low too. Some of these are really easy. So here we go. Program has provided to you what happens if you run it on the command line. Okay. In the program, oh, you must make it executable. Okay. Try running it by adding a dot in front of F. Okay. Okay, so let's try this. Download this. Then. Oh, hold on. I gotta share my entire screen. Give me a sec. Okay. Okay, loading. I'm probably just gonna show you guys like how to run these files on Linux. Oh, I guess so slow. Bro, what? Yeah, there we go. Okay. So let's move this in here on the desktop. Okay. The terminal. So right now we're in the root folder. Let's go to the desktop. And then we should see a run file somewhere, right over here. So we need to make it executable. So basically we need to make it so that it can run. So we just do chmod plus x, so make it executable, and then the file. Okay. And then we can just run it, I'm pretty sure. If we run it, right, literally just gives us the flag right here. Okay, cool. What about the other one? Do the second one. Okay, another program, but this time it seems to want some input. What happens if you try to run it on the command line with input hello? Okay, so literally gives you the command here. Very well. Okay, so once again, put it on the desktop. And then you make it executable. Let me just delete this one. Bro, parentheses is messing Linux up. Okay. Okay. Oh, there's an extra space. Okay. All right, there we go. And then if we run this again, normally, I don't think it's gonna run, or it's not gonna work. Run this file with only one argument. Okay. So I told you to run like this, right? So you want to run with the hello. Oh, I gotta remove the quotes. Okay. Yeah, so if we run it, we get the thing. Okay. All right, let me find a good example of like really simple, but like not this simple, you know. Yeah. Okay. Do this one. You patch me that I try that. Okay, run this Python program in the same directory as this encrypted flag. Okay. Let's download both. Okay. All right. So if we run this, or we gotta first make it executable, right? Patch me. Okay. Then if we run patch me flag, it says there's a syntax error. Okay. Very interesting. We always want to fix that, right? Wait. Okay, so let's just look at what it does. So we can do this by just putting up. I don't want to open up then. Just do this. It's gonna load. Okay. Okay, so we have a lot of complex Python stuff, right? We have a key here, which is the one we inputted to. Can somehow use that, and then we have a while loop here, and then it's comparing the lengths of the new key and the secret key. Okay. While the secret key is longer, we create this. Basically, we just got to debug what's wrong with this thing. Yeah, so it basically checks if our input is equal to the password. Right. And that's pretty hard. But hold on. Before we do that, for some reason there's a syntax there. I don't think that's supposed to happen. Should give it a run. Oh, is it because what? I'm not sure what it's talking about, honestly. It shouldn't have this issue. What if we let's do this. Let's run this in Jupyter. Oh, but it needs a file. Wait, can't do that. I don't know why there's a syntax error, but how I would do this, basically it wants you to type a password that's equal to the hash. That's obviously really hard, right? So what you would want to do is make it, so we want to make it so that if it's not equal to the hash, and prints out the flag. So to do this, we just need to do, I think we just need the equal sign to not equal. So it's equal sign right here. If the user password is equal to the hash, if we just set this to not equal, which is the exclamation and then equal, it should work. Yeah. Reverse engineering is really confusing. You guys, I mean, honestly, I might not be the best resource, but if you guys have any questions, you guys can always just message me. But I don't want to keep you guys too long. I hope you guys like